Okay, so we've been talking about vertical asymptotes and what they look like on graphs. You can see that in the previous video, but this is actually the calculus definition of a vertical asymptote. And this says if f of x approaches infinity or negative infinity as x approaches c from the right or the left, then the line x equals c is a vertical asymptote of the graph of f. Now, theorem 1.14 is probably what you learned as the definition of a vertical asymptote or something similar to this in maybe a pre-calculus course. But this is just kind of a method for finding vertical asymptotes. And there's two different ways that you can look at it. The first thing that you want to do in every case before you start looking at vertical asymptotes is you want to cancel anything that's redundant in the numerator and the denominator. So you would factor and then cancel if appropriate. So this says if we let f and g be continuous on an open interval containing c, if f of c is not equal to 0, g of c is equal to 0, and there exists an open interval containing c such that g of x is not equal to 0 for all x not equal to c in the interval, then the graph of the function h of x equals f of x over g of x has a vertical asymptote at x equals c. So if we're looking for a vertical asymptote, it's most likely going to be either a rational function or some particular trig function that has a denominator like tangent equals sine over cosine. The denominator would be considered to be a cosine, so it would come from that. So what we're looking at is a rational function where the numerator is not equal to 0 at c and the denominator is equal to 0 at c. Another way to think about it is that we're looking for the non-removable discontinuities. So if it makes the numerator 0, that means that something could have factored out, and that is just a hole in the graph. So let's take a look at an example. We want to find all vertical asymptotes of the following function. So I've got f of x equals 1 over 2x plus 1. And I'm just going to do a quick check. 1 and 2x plus 1 have no factors in common, so we are good to go there. So I am just going to set the denominator equal to 0. So 2x plus 1 equals 0. That gives me 2x equals negative 1, which gives me x equals negative 1/2. And then I'm going to check to make sure that the numerator is not equal to 0. Well, that would mean 1 not equal to 0. So this tells me that f of x has a vertical asymptote at the line x equals negative 1/2. Now, when you are describing vertical asymptotes, these are lines. You have to write x equals negative 1/2. If you just put negative 1/2, you will be counted off. You must write x equals. This is probably one of the most common emails I get with regards to WebAssign. People would put a negative 1/2, they'd get the answer wrong, they've worked it a million times. Why is it wrong? It's wrong because you forgot the x equals almost every time. Now with a problem like this, again, there's kind of two different ways to do it. You could take a look at it first and note that this is x minus 1 over x minus 1 times x plus 1. So this would cancel, and this is 1 over x plus 1. Now that x minus 1, remember, still affects the continuity. So the x minus 1 equals 0, or x equals 1, is going to be a hole in the graph, whereas the x plus 1 equals 0, or the x equals negative 1, is going to be a vertical asymptote. So in this case, we would say we have a vertical asymptote at x equals negative 1. So that's one way that you can look at it. If you don't want to do that, you can always set the denominator equal to 0. So that would be x squared minus 1 equals 0. X squared is 1. So x would be plus or minus the square root of 1, or plus or minus 1. If you check the numerator, make sure it's not 0. then you would plug both of those in. So that would be if x equals 1, that would give you negative 1 minus 1, which is not 0. I'm sorry, that would give you 1 minus 1, which is 0. So that means it's not a vertical asymptote. It would have to be a hole. And x equals negative 1, that would give you negative 1 minus 1 equals negative 2, which is not 0. So there is a vertical asymptote at x equals negative 1. So either way works, whichever one you're more comfortable with. The only place where this method can kind of get you into a little bit of trouble is if you had something like x over x squared. Technically that does have a vertical asymptote at x equals 0. So that would be the only type of case where you would need to be a little bit careful with that. So again, with one like this, either method is fine. If you wanted to go through this with factoring, you would factor the top, and that would give you x plus 3 times x minus 2. And if you factor the bottom, that would give you x plus 3 times x minus 1. So you can see that that cancels. That's a removable discontinuity. So x minus 1 cannot be 0, so x cannot be 1. Or if you wanted to set the denominator equal to 0, you would get x equals 1. So if we set the denominator equal to 0, if we check the numerator, we would have, from the original problem, 1 squared plus 1 minus 6 is definitely not 0, so that means there is a vertical asymptote at x equals 1. So again, you can start from the beginning and set the whole denominator equal to 0, or you can go ahead and take out those removable discontinuities if you want.